Today we're going to discuss pedigrees. Pedigrees with genetics is a way to envision the entire lineage or family and to kind of try to determine inheritance. So we've talked about the different types of inheritance, but we want to take a second to look how these can be passed through an entire family, not just from parents to child, but then what about to grandparents? How does it look in terms of aunts and uncles? Like, can we figure out how this is inherited by how this trait's inherited by just looking at an image? And so a pedigree is like a chart that'll help you figure that out. And that is one of your standards for this class, is that you are supposed to be able to identify a trait in a pedigree. So let's get started. First of all, there's some things you need to know, so make sure you're taking notes. You need to be able to determine what the symbols are on the particular chart. So females are circles, males are squares. Okay, so when we look at a pedigree, we're going to be looking at, it might look something like this for one small family group. That's female, that's a male. Okay, and so if there is a trait, and pedigrees never tell you, you need to know this for sure, listen carefully, pedigrees never tell you if the trait is recessive or dominant or how it's inherited. It simply tells you if someone is affected or has a particular trait. So at the top of the pedigree, there might be a title like attached earlobes. Okay, so if you have attached earlobes, then you would be affected by this trait. So if you are affected by this, so a female, an affected female, I have trouble with A versus E on affected. I'm not sure if that's the right one, but honestly, don't care. And if you are an affected, might be E. Once again, don't care. Okay, so you fill them in if they have it. That's how you can tell on the pedigree what's going on. Okay, so say that we have male, female. They have 3 offspring. I'm going to identify these lines for you. If you want to go ahead and draw this tiny pedigree in your notes so that you can identify some of the lines here. So basically what you have to know is what all these symbols and lines mean so that you can read the pedigree. Okay, so here, this right here is called a mating line. We don't call it a marriage line because many of these pedigrees are like for like dogs or racehorses or even plants and things. And I don't know about you, but I haven't been to a puppy dog wedding in a while. So typically, I mean, we're not always talking about humans. Now, we tend to talk about humans in biology because it's interesting. We like to talk about human things in biology, but many times these pedigrees are not for humans. So we just call that a mating line. This is offspring line. And when you have multiple offspring, then you have to make a bracket for them. Okay, so pretend like we only had one offspring. Okay, it would just be like that. Like, then you would just have a single offspring. But if you have more than one, you have to make a bracket. And be super careful not to draw the line in between them, because then you're indicating a mating line in between your siblings, which, I mean, if you're plants or dogs or who knows, all bets are off. But if that's not what you're intending to have, then please don't draw your line there. Now, we probably won't be drawing a lot of these just because of the remote nature of our class. Normally, we draw pedigrees for fun and to get you really used to them. I would practice drawing some. But when you're in class, you're going to be reading them. So you're going to be interpreting them. And so you'll get one and you'll have to interpret it. Okay. So typically, whenever you do your offspring bracket, you put them in age order. So that was thunder. Sorry. So it kind of scared me. So left to right, you'd put them in age order. So it would be like, this is the oldest girl. And then this is the middle child, this is the son. And then this is the youngest. Now, if you're going to actually have offspring get married, like the next generation is starting and they're going to have children too, then now the ones that come into the pedigree from outside, like marry in or mate in, they don't matter how old they are. So like if this one happens to be the oldest of all of these, you don't have to put it over here on the left. Like that doesn't matter. Okay. All right. So let's see. Let's number it. Numbering is super important because it allows you to talk about the pedigree, because sometimes you'll get a multi-generational pedigree going And it's like, if you don't have names on them or something, then you're trying to interpret the pedigree. Well, you better know how to identify which individual you're interested in. And so how we number them is we number them. I'm going to erase this little key here. So I'm sure you've got it. If you haven't, you can rewind and get it. And so we do it by generation is Roman numeral. So Roman numeral 1 is our first generation. Roman numeral 2 is our second generation, and this is Roman numeral 3 for our third generation. And if I had these ones get married and have kids, or mate and have offspring with another individual, then I would have a fourth generation, which would be IV, okay? Now, once I've got that in, I'm going to erase my little notations here so that we can just look at a pedigree like normal. Okay, once I have my Roman numerals on, then basically what I'm going to do is I'm going to number each person. Now, this is after my pedigree is finished. So I need all of them, all the outsiders married in or mated in, because we number from left to right. And it doesn't matter if you were born into the family or you were a partner mated into the family. You get a number, okay? Because all the numbers are for is to identify. So I can say person 2, 3. Do they have attached earlobes? And is it a boy or girl? And you would say person 2, 3, person 2, 3 is male with attached earlobes. Oh, I guess I probably better finish filling in my little chart here. Okay. All right. So that's first of all. So now we've got the basics. Now we need to figure out the big thing is, how do we identify what genotypes these have? So that's the big goal with pedigrees for us in Bio 1 is determining genotypes. So the first thing you have to determine is, how is this inherited? Is this inherited as a like codominant? Okay, so pedigrees nicely show automatically codominance. Like you don't have to wonder if it is, because that's a third phenotype. And so right now I only have 2 phenotypes, either attached or not attached. Okay. If I were to have a codominant or an incomplete, I would have 3 phenotypes, and you could clearly see your heterozygous individuals because of that phenotype. So we're going to kind of stick to, we're going to be looking for 2 different kinds of inheritance. We're going to be looking for Mendelian. And in Mendelian, we need to identify if it's recessive, if the trait that is filled in is recessive or dominant. Okay. And we're also going to be looking for sex-linked. And once again, is that recessive or dominant? Okay, so that's what we're trying to identify. So basically, you have 4 options whenever you're looking at, for our class. Okay, so if you went up higher in biology, you might have to get a little deeper. But for our intents and purposes, we're just looking at 4 options. Is it a Mendelian trait? And if it is it Mendelian recessive or is it dominant? Is it a sex-linked trait? And if we think it is it recessive or dominant? Okay, now I'm going to tell you right now, this sex-linked dominant and this Mendelian dominant, almost impossible to tell apart. So probably you're not going to get very many of these. So you can just sort of mark that one off as, unless you have other information that tells you that it, for some reason, tells you that it's sex-linked dominant, then you probably are not going to be able to determine the difference between Mendelian dominant and sex-linked dominant. They're very, very, very similar in their inheritance pattern. Because if you have one gene that expresses it, then you have it. And so males and females would be the same. Like they have one X. So if they have one X that expresses it, they have it. So I would probably even hazard to say I wouldn't answer that one unless there was extra information given in the prompt that made you think that it was sex-linked. Okay. So basically you're down to 3 options. Mendelian recessive, Mendelian dominant, sex-linked recessive. That's about it. Okay. Okay. So let's look here and try to determine what's going on. First of all, we're trying to determine if attached earlobes is Mendelian or sex-linked. Remember that if a dad has it, then he would not be passing it on to his sons unless mom is a carrier of it as well. Okay, so she could be. But also she would have to be a carrier. This girl would have to get both. So could possibly happen. Then to their married son has it. Could be sex-linked, but I'm not leaning in that direction. Okay, I'm not leaning in that direction. First of all, actually, I'm not there at all because mom has it right here and son doesn't. So definitely not sex linked. Just think, if mom had it, then she would have to have, if it was sex linked and we said recessive, right? So if it's sex linked recessive, then she'd have to have both. So this kid would have to have it. So definitely not sex linked. So we're marking sex linked off of that one because if a female has it, then her son has to have it too. Because that's the only X she had to give, and dad gives a Y in a sex linked trait. If you need to review that, go back and watch the video on sex linked traits. Okay, so then we're down to Mendelian, and we need to decide if it's recessive or dominant. How could I know? Well, basically, this is where you start doing some Punnett squares to try to help you out. But I'm going to tell you one thing to look for. Guys, this is critical thinking. Like, you have to think your way through pedigrees. There's no, like, rules to follow. I've heard some people that have, like, some cute little phrases and stuff, but there's no real rules to follow. So you need to be able to think your way through it. Here is your one that tells you right here. Because if you have two parents that do not have the trait, and they have an offspring that does, there's only one way that could happen. And that is if both parents were carriers. And this is not a sex-linked trait. So if they were both carriers and it's recessive, then they have 25% chance of having, oh, sorry, that's supposed to be biggie. 25% chance of having an attached earlobe. So that would be it. Okay, so then that tells me right now that this is a Mendelian recessive. Why? Because if these were dominant, if these were recessive, so let's pretend the other way. So if we said, no, the trait's dominant, attached earlobes was dominant. Okay, so you're telling me that these aren't attached, so they're both recessive. How in the heck could they come up with a kid that has that if neither one of them had it? Okay, so a dead giveaway, if they give it to you, a dead giveaway is that two parents that do not have the trait or do. Ooh. So if we were going to look the other way and say these were both filled in, they had a kid that wasn't filled in, then you'd say, ooh, that's a dominant trait. Because what you're looking for is two parents that are the same phenotypically. So they phenotypically look the same, and they have a kid that's phenotypically different from them. That child is recessive. Because the only way phenotypically parents that are the same can have a child that's different from them is if they are carriers or if they are heterozygous and the child is the recessive. Okay, that's the only way that works. Most of your pedigrees will give you a little family like that to determine, to help you determine that. Okay, if they don't give you a family like that, then it should be a numbers game. Like if you have a lot of people in the family, it's probably dominant. If you have very few, it's probably recessive. But you'd want to do a few Punnett squares to make sure that you're correct, that it's a possibility. Okay, so let's bump over and do one little practice pedigree. I'll show you real quick. Let me figure out which one it is. Here we go. So let's do one practice pedigree here and try to figure out what's going on here. All right, first of all, this one is numbered differently than I told you how to number it, which is frustrating, but the way I taught you is the correct way to do it, the scientifically correct way to do it. So this should have Roman numerals, so I'm going to pretend like it does. So I am looking for a family that can help me determine if this is sex-linked, if it's Mendelian, dominant, or recessive. So first of all, look at family, look at person 1-4. Okay, person 1-4, who is right here. So person 1-4, okay, she has the trait. If this were sex-linked, remember sex-linked recessive is the only one we're looking for. If this were sex-linked, that would mean both of her exes would have the trait. I don't even know what the trait is. I don't care. So both of her exes would have it, and he does not have it, meaning it would be XY. So what does that mean for her sons? If both of her exes have it, all of her sons have to have it. Okay, this is not sex-linked. Not sex-linked. Okay, so first of all, we can cross off sex-linked because if mom has it, then her sons have to. Not sex-linked. So then it's down to Mendelian. So with Mendelian, what I'm looking for is a family that does not have, parents that are phenotypically the same. So here's a set of parents that are phenotypically the same. Here's a set of parents that are phenotypically the same that have offspring that are different from them. Here's the set. So this is, let me see, 1, 2, 3, 4, 5, 6, 7. So this is persons 2, 6, and 2, 7. And they are the same, but all their children are the same too. So that didn't help. How about persons here? 1, 2, 3, 4, and 5. Persons 2, 4, and 2, 5. Phenotypically the same. And they have a child different from this child is recessive. So then that means this filled in is recessive. So that was just me trying to figure out if this trait is recessive or dominant. Now that I've got that, now I know all of the ones that are filled in are recessive. So I can say little e, 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 little e. Oh, it's starting to sound like Italy. Okay, fill all those in. Now I go back and I try to determine if these are homozygous dominant or if they are heterozygous. And that's the game. That's the pedigree game you're playing. Well, I mean, you have a pretty strong case here that this person 1, 2 is homozygous dominant because all 3 of their children turned out to not have the trait. And so if that's the case, I know these are all heterozygous regardless because they got one dominant because they're not filled in. So they have to have one dominant. And then they got a recessive from this parent. This parent only has recessive to give. And so if you have a filled in on the recessive, all their children at least have one recessive. So these are all heterozygous. Hetero, hetero, hetero. Okay, what about this one? Right, hetero as well. How do I know? Because it's not filled in, so it has a dominant, and its parent was recessive. So the parent gave it a recessive. So this one's hetero, homozygous recessive, hetero. Okay. All right, so down here to this row, homozygous recessive, obviously. Hetero, yeah. Because parent 2, 1 here gave them a recessive. How about this one? This one I do dominant letter and then an underscore, like a line that indicates to me, I don't know. It's either homozygous dominant or heterozygous, but I can't tell from this pedigree. Same with this one. Okay, this one's homozygous recessive. Because if you do a heterozygous pedigree, you know that you have a 25% chance of having a homozygous dominant child and a 50% chance of having heterozygous. So you're like, well, more likely they're heterozygous. Could be, but they also could have both got that flip of the coin that gave them homozygous dominant. This whole family is homozygous recessive, and this one we've already done. Okay, do some practice problems that you have for you and see how you do. Let me know if you need any help. There will be some that are dominant, some that are recessive, some that are sex-linked. See how you do, okay? I hope you have a great day, and I will see you soon.